The safest agent is not the one with fewer tools. It's the one that can pause a risky action, ask for approval, and resume without losing state. This is the pattern you'll be able to implement by the end, which pauses for human approval after planning, and then resumes to act with optional edits. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Human-in-the-loop agents solve a practical problem. Models can plan and act, but some actions are sensitive. You want a system that drafts a plan, waits for a human to check it, and then continues exactly where it left off. That avoids accidental emails, costly API calls, or dangerous database writes. People use this pattern when cost, safety, or compliance matter, and when a short human check greatly reduces risk. At its core, the idea is simple. Let the agent make a plan, pause execution, and hand the plan to a reviewer. Accept and approve, edit, or reject response. Then resume with the same internal state so nothing gets lost. The strength is clear traceability and control. The trade-off is a small pause and a need for persistent state. LangGraph helps by wiring nodes and saving state for you, so you focus on decision logic instead of plumbing. We will build a tiny LangGraph app that plans, pauses for review, and then either continues or stops based on the reviewer. You will see a strict demo flow, so the pattern is obvious. The code is small, and it mirrors what you would use in a test harness or a lightweight review UI. Now, let's start with the basic pause and inspect behavior. This snippet builds a tiny LangGraph that proposes a plan and then pauses for human review using an interrupt. The function plan raises a pause via interrupt with a short plan payload, which stores the suggestion in state. The graph wires plan into a trivial act node and compiles with MemorySaver, so state persists across pauses. The app.stream call advances execution until the interrupt, then returns control to the caller without running the act step. Finally, app.getState reads the current values from the persistent checkpoint. The printed plan confirms the agent has paused with a concrete proposal ready for review. Next, we'll resume a paused run by sending an approval decision. This example resumes the previously paused LangGraph run by sending an approval decision into the interrupt. The app.resume call supplies a small dictionary that represents the reviewer's approval, which unblocks the plan node and allows the graph to proceed. The act function then executes using the stored plan and writes a compact result back into state. Next, app.getState fetches the latest values so we can inspect the outcome. The printed action result shows the graph cleanly continued from the exact pause point, demonstrating a reliable handoff between planning and execution. Now, we'll add a lightweight safety assessment step before the action. This code extends the LangGraph with an assess node that scores actions and selects the safer choice. The function assess computes simple risk values for search and email, then writes the chosen action and its risk into state. The act node now reads the choice and risk to produce a final result string that encodes the decision. After compiling, app.stream advances to the plan interrupt, and app.resume approves the plan to trigger assessment and action. If you increase the email risk or decrease search risk, the chosen action and the printed risk value will change accordingly. The printed selection confirms a risk-aware choice was applied. Next, we will let reviewers edit the plan text during the pause and have the graph honor the edits. This snippet lets reviewers edit the plan during the LangGraph interrupt and then resumes with the updated content. The function plan calls, interrupt, and reads back the return dictionary to accept an edited plan string. The assess node parses allowed actions from the plan text, filters to recognized options and picks the minimum risk choice among those. After compiling, app.stream pauses at the review gate. app.resume then injects an edited plan of email only, which the assess function honors. If you instead pass search only, the choice flips and risk drops accordingly. The printed choice and risk show that human edits directly steer execution. Finally, let's make a safe rejection path so the workflow can stop cleanly. This code adds a rejection path so LangGraph can end safely without acting when a reviewer declines a plan. The function plan reads the interrupt response and sets plan to rejected if the reject flag appears. The small route function returns assess when the plan is not rejected, otherwise end, and add conditional edges wires this branching into the graph. After compiling, app.stream pauses for review, and app.resume sends a reject decision that short-circuits the workflow. If you resume without reject, the graph proceeds to assess and act. The printed Boolean confirms that a rejected plan prevented any downstream action. In a real project, this pattern maps directly to a review UI or an audit log. The plan payload becomes the review card. The resume payload is the reviewer decision and optional edits. MemorySaver or a similar persistent store guarantees you can resume days later without losing context. Recap. It is a simple pause, review, and resume pattern for safer agents. Use it when actions have cost or compliance risks and you want human oversight. One caveat is the added latency and the need to manage persistent state across pauses. Next step, scale this exact approach by adding timing and accuracy checks and running the same workflow on a larger corpus so you can measure reviewer latency and decision impact. If practical AI engineering helps, subscribe and watch the AI engineering videos.